Okay, here's the big meat of the problem, okay? The second trend, finding the volume. Whether it's a revolution problem where you're rotating a shape or cross sections, you could earn a lot of points, okay? I'm going to focus heavily on the setup because that's really where the majority of your points are. So one thing that you guys have to know, there were two different methods that you guys could use for a revolution. It was a disc or washer method, or it was a shell method. What you guys have to understand is that the shell method is actually a BC concept, okay? So they don't expect you to use the shell method, but you can. Okay, so the scoring guidelines may not have the shell method, but if you end up with the same answer, you're still going to get points for it because equal is equal, right? Okay, so just keep that in the back of your mind. Okay, so this one here is no calculator. Usually for volume problems on a non-calculator question, they'll just ask you to set it up and not evaluate because generally it's really tough to do by hand, okay? All right, find the volume of the solid generated when r is rotated about y equals 1. So what you do, you draw a y equals 1 line, which is right here, and we're revolving around there. So since the axis of revolution is horizontal, you want to make sure that your rectangle is vertical, because vertical means that you get to keep your functions in terms of x, right? Now, in the rare occasion that your equations are in terms of y, then you would want to favor a horizontal rectangle, okay? But since the equations are in terms of x here, I like to do the bare minimum and not change these equations. So I want to make sure that I favor a vertical rectangle. So the only question here is, what method would you guys use? How are they related? Notice how that this is perpendicular, not parashell, perpendicular. So you would want to use either a disc or a washer. But obviously, if you spin this, there's going to be a definite gap in between here. There's going to be a hole. So we know that this is going to be a washer. So I'm going to go ahead and call it washer. You don't have to write washer on your exam. This is just something for you to note. On the AP exam, you can just go straight to the setup, okay? Okay, so we're going to go ahead and have pi integral, okay? I know that this is going to be dx, and this is going to be outside squared minus inside squared. Again, you guys are refreshing here, okay? Okay, the bounds are pretty easy. The region starts from 0 all the way to 1/2 here. Okay, so for instance, like if you didn't know what to do next, you could probably get a point or two just from the limits or the bounds. Okay, so definitely always throw in what you know. So remember, the outside, you start from the axis of revolution to where you're about to exit the region. Okay, and then the inside is right where you're about to enter. Okay. I want to see if you guys remember, so go ahead and pause here, press play when you're ready. Figure out what the outside and the inside is. Okay, I know that from here to here is 1. And this tiny little nugget right here is your f of x, which is y1. I think we labeled it last time. But again, use y1 if you declare it. So I'll just write it here. Let y1 equal 8x cubed. Okay, so I know my outside will be 1 minus y1. Okay, so the other one must be 1 minus y2. Okay, so if you're confused about the setup, ask me questions, okay? You could definitely write 8x cubed and sine pi x if you wanted to instead. But again, if you declare it, you could always use the shorter version. So there we go. I declared that y1 and y2 are those. And there you have it. I set it up. and I'm all done because it doesn't ask me to evaluate. Okay, let's take a look at the scoring guidelines in 2011. Okay, they used f of x and g of x, which is fine because it was declared in the problem. But I used y1 and y2, which is the same thing. They did a little bit extra and wrote out the actual f of x and g of x, right? Not necessary. Okay, take a look at the point system. The limits and the constant. Remember, the limits are the bounds. The constant is that coefficient in the front, that pi. So if you got this, they gave you 1 point. Okay? If you got the integrand, everything on the inside, they give you 2 points there. Again, very easy to do with practice. You don't have to solve for it. Answer exactly what they're telling you to do. Because chances are, if you do more than what they ask you to do and you do it incorrectly, they take away points. Again, be stingy with your answers, okay? Okay, I'll do one more. Let's do one with a cross section. Okay. Let's do this one here, okay? 2009 Form B, Part B. Okay? So if I'm reading this quickly, I notice it says cross sections perpendicular to the x-axis, okay? Perpendicular to the x-axis right away tells you that you're integrating with x, okay? If it's perpendicular to the y-axis, like this problem in the previous section right here, then you would have to integrate with y, but we'll talk about that later. Okay, so they tell us that the cross sections are squares. So I'm going to draw a sample. Since it's perpendicular to the x-axis, I'm going to go ahead and draw a vertical rectangle. And there, on top of it, is a square. So you're stacking a bunch of squares on top of this region. You're not spinning this. Okay? So remember, the volume of cross sections is just the area of your cross section. So the cross section here is just the area of your square. Okay, so I'm going to use the area of the square, which is something squared. If it was a triangle, you would use the area of a triangle. If it was a semicircle, you would use the area of a semicircle, okay? Okay, so here, the height or the length is going to be, the height here is going to be determined by the length of one of the sides of the squares there, okay? So to get that height, that's really just top minus bottom, which in this case, it'll be the top function is clearly the square root of x, and the bottom function is clearly that linear function. You could use y1 and y2 here, but this is short enough for me to write the square root of x, okay? I'll leave that up to you. Again, there is no pi out here because we're not revolving it, and it's not a circular cross-section, okay? The last thing left is, well, where does the region start and stop? It starts from 0 all the way to 4. Boom. Okay, this is a calculator question, so we're going to plug and chug here. I'm not going to use y1 and y2 because it's so short, so I'll do math 9 from 0 to 4. Parentheses, square root of x, jump out of that square root, minus x divided by 2, close it, then square it, dx. And then I'm getting, if I round it, 0.533. Okay, let's take a look. Let me go ahead and copy this. Okay, 2009 Form B. Let's find it. This is what I got here. Oh, this is a non-calculator question. Whoops. Okay. I thought I was in the calculator active section. Okay, so I guess we can't use the calculator. Nevertheless, okay, at the bare minimum, we get 1 point for our integrand. So all of this in here, we get a point. So we have to do a little bit of work here, okay? So there is a little bit of algebra to it because you need that algebra to get to the calculus, okay? So when you square that, it's like foiling. You're writing it out twice. Some of you know the shortcut, and that's fine too. So basically, if I FOIL that out, I should get x minus plus x squared over 4, and then minus 2x over 2 radical x. Okay? And eventually, when you clean this up right here, that's a bad highlight. Okay? You eventually will get this. Okay? Now, if you have questions on that, just let me know. But I'm actually going to move on from there, okay? Yeah, so after that, you're going to integrate each term. You're going to get x squared over 2, that, and that. Okay? There's still calculus to be done. What I would do is I would plug in my upper, which is 4 squared over 2 minus 2 times 4 to the 5 halves over 5 plus 4 to the third over 12 minus 0 squared over 2 minus 2 times 0 to the 5 halves over 5 plus 0 cubed over 12. Now, if you're asking, well, that's a lot of writing, Mr. Lee. It is, but the cool thing is you could just leave it there because equal is equal. Even if you think it comes out to 0 altogether, I would still encourage you to plug in 0 because sometimes it doesn't, okay? And I would rather write all of this than to try to evaluate all of this, okay? So you don't have to go all the way to 8 over 15 to get that third point, okay? So again, I wouldn't say that this was super easy in terms of getting the points. The big obstacle is probably a little bit of the algebra there. But worst case scenario, I think you would agree that at the very least you should get the integrand. Okay? Getting 1 point here is fine because in part A, you would have easily got that 3 points, I hope, with the 1 point here, which is 4 out of 9. So you're really trying to get all that you can get, okay? Even if you make a little bit of error in between, you want to get all that you can get there, okay? Yeah, and that's it. You know, the only thing that you got to watch out for with cross sections is if you're dealing with perpendicular to the y-axis, or if you're dealing with like semicircles or quarter circles, in which I'll tell you to go back to that video or your notes because I did emphasize it, okay? So try it out and text me if you guys have any questions.